Hello, welcome to Honors Algebra 2 Final Exam Study Guide. Yep, we made it to the end, guys. Good job. I'm going to go through each of the questions on the study guide. Remember, the actual final exam will be just like it, except it is multiple choice. So that kind of makes it a little easier for you. There will be a total of 40 questions, just like on the study guide, and the types of problems will be the same. Okay? All right, so let's get started. The first part, questions 1 through 13, those are factor questions. So I am just asking for the factors. I'm not asking you to give me solutions. In other words, your answers should not be x equals 1, x equals 2. No, your answers should be in factored form. Okay? Notice there is no equals signs here, and we're not solving any of these. For the actual answer, we are just factoring. So let's go ahead and take a look at the first 7 problems. If you look at the first 7, you'll see something very interesting. Every single problem in 1 through 7 has 4 terms. When you are factoring a polynomial with 4 terms, we're going to use the process known as grouping. And what grouping is that you group the first 2 terms together and you group the second 2 terms together. You're going to factor from here and you're going to factor from here. And I'm going to go ahead and do each one with you right now. So I'll do 1 through 7 now. Okay? So number 1 is 35x to the third plus 5x squared minus 14x minus 2. So once again, we're going to do the whole grouping thing. Just organize this. We're going to do the whole grouping thing. We are going to group these 2 guys together and these 2 guys together. And when you look at these first 2 terms, you are going to pull out, or you're going to factor out, the greatest common factor. From 35 and 5, the greatest common factor is a 5. What that means is that I can pull a 5 out of 5 and get 1, and I can pull a 5 out of 35 and get 7. And then for my variables, I have x to the third and x squared. The one that I can pull out of both is x squared, because I can take x squared out of x squared and get 1, and I can take x squared out of x to the third and get x. So this is the greatest common factor, and then we are going to pull that out, and we're going to be left with 7x plus 1. All right? Now we're going to do the same thing over here. Now the greatest common factor here, you can pull out a 2 and you can pull out a negative 2. The decision to whether to pull out a negative or a positive really has to do with this factor here. We want there to be on this side also a 7x plus 1. So in order for that to happen, using these 2 numbers, we would have to pull out a negative 2. So the factor I'm pulling out of here is negative 2, and I'll also be left with 7x plus 1, because negative 14 divided by negative 2 is 7. Negative 2 divided by negative 2 is 1. Now if you've done this correctly, you will have this term and this term be identical. So that is the common binomial factor, and we're going to write it here. And then for the second factor, you're going to take what is left over. You have 5x squared minus 2. That is your second factor. Okay? So that's how we do grouping. I'm going to go a little faster now for the others. So we have 7x to the third plus 4x squared minus 14x minus 8. Again, we're going to group here and group there. From these two, the greatest common factor is x squared. You're going to be left with 7x plus 4. From here, the greatest common factor is going to be negative 2. And again, you'll be left with 7x plus 4. And so our common binomial factor is this guy. So we write him here, 7x plus 4. And what is left over? X squared minus 2. Number 3. We have 4n to the third minus 2n squared plus 14n minus 7. Again, we're going to factor these two, and we're going to factor these two. Here we're going to pull out a 2n squared, and we'll be left with 2n minus 1. Here we're going to pull out a 7, and we're going to be left with 2n minus 1. Our common factor right here and here, so that is 2n minus 1, and we have this left over, 2n squared plus 7. Okay, number 4. We have 5p to the third minus 3p squared minus 10p plus 6. Again, group these two, group these two. Here we're going to pull out a p squared. We're going to be left with 5p minus 3. Here we're going to pull out a negative 2, and we'll be left with 5p minus 3. Once again, the common factor, 5p minus 3, p squared minus 2. Okay? Let's take a look at number 5. Still doing the same thing. We're going to use grouping. So these two will go together, and these two will go together. Here we're going to pull out an 8m squared, and I'm going to be left with m plus 7. Here I'm going to pull out a negative 1, and I'm going to be left with m plus 7. Notice I did that so that these two would be the same. I pulled out a negative 1. Okay, that's a little trick you do. So your common factor is m plus 7, and you are left with 8m squared minus 1. Okay, let's move on to number 6. Number 6, we have 5b to the third minus 35b squared minus 2b plus 14. Okay, for this one, we're going to group these two guys together and these two guys together. Excuse me, we're going to pull out a 5b squared, and I'm going to be left with b minus 7. And then over here, I'm going to pull out a negative 2, and I'm going to be left with b minus 7. And that is going to give me b minus 7. And once again, 5b squared minus 2 is what's left over. Number 7, we have 49 r to the third plus 42 r squared plus 35r plus 30. So let's see what we can pull out. These two will be grouped together, and these two will be grouped together. So here I can pull out a 7r squared, and I'm going to be left with 7r plus 6. Over here, I'm going to pull out a 5, and I'll be left with 7r plus 6. So once again, this is your common factor binomial, and you'll be left with 7r plus 6. And what is left over is 7r squared plus 5. So that was 1 through 7. Let's just take a look real quickly at the grouping section. All right? Then we have 8 through 13. And these are going to be a combination of 3 types of factoring problems. The 3 types of factoring problems are, hold on, let me get this nice and straight. Sum of cubes, difference of cubes, and difference of squares. Now when I say squares and cubes, I mean perfect cubes and perfect squares. All right, the one everybody knows is difference of squares. If you have a squared minus b squared, that is equal to a plus b, a minus b. Yes, you have to memorize these. There's no other way around it. So you need to memorize this one. You need to memorize sum of cubes and difference of cubes. Sum of cubes would be a cubed plus b cubed equals a plus b, a squared minus ab plus b squared. And then difference of cubes looks a lot like this, except it is a to the third minus b to the third equals a minus b, a squared plus ab plus b squared. So you need to memorize them. No other way around it. Make sure you know all 3. All right? So let's go ahead and do numbers 8 through 13 now. Number 8. 64m to the third plus 1. All right, you take a look at this and you notice that this term is a perfect cube. The cube root of 64 is 4, right? 4 times 4 is 16, 16 times 4, 64. The cube root of m to the third, that is m, and the cube root of 1 is 1. All right? So if we go back to our equation from the previous page, we had a to the third plus b to the third equals a plus b, a squared minus ab plus b squared. Okay? So this term here, that is your a, and this is your b. Now the cube root of this is, like we said, 4m. So a is 4m, and the cube root of 1 is 1. So a is 4m, and b is 1. So this is going to be a plus b, which is 4m plus 1. and then a squared, which is 4m squared, that's 16m squared, minus a times b, that's just 4m, plus b squared, which is 1 squared, which is 1. And that is your final answer. Okay? Let's take a look at number 9. Number 9, we've got 4a to the third plus 256. Now, when you look at this one, that's not perfect cubes. The way it looks right now, it is not something that we could use perfect cubes with, because 4 is not a perfect cube. So what you need to do is remember that whenever you're factoring, always, always, always look for the greatest common factor. Pull out the biggest factor between these two terms. And if you take a look, 256 is divisible by 4, and it gives us 64. So I'm going to pull out a 4, and I'm going to be left with a to the third plus 64. Well, at this point, we do have the sum of perfect cubes right here. So your a is just a, right? And your b is going to be the cube root of 64, which we just looked at was 4. So once again, this is going to be a plus b. So it's going to be a plus 4. And then we're going to do, oh, and do not forget this 4 out here. Please do not forget that 4 that we factored out. So it's 4 times a plus 4, and then we have a squared minus a times b, which is just going to be 4a, plus 4 squared, which is 16. And that is your answer. Please do not forget this 4 that we pulled out, okay? So that's very important. That is the complete factoring. All right, number 10. For number 10, we have 125 x to the third plus 216. Okay? For this one, we can see that this is perfect cubes also. The cube root of this whole thing, which we're going to call a, is 5x. And the cube root of that whole thing, which we're going to call b, is 6. So once again, this is a, this is b. So it's going to be a plus b, 5x plus 6. Then a squared, which is going to be 25x squared, minus a times b, that's going to be 30x, plus b squared is 36. Okay? Again, this is all coming from up here. We're using the same thing. These happen all to be sum of cubes. But be ready on the final to have a difference of cubes, because you never know what will get generated. All right. Number 11. Here we have x squared minus 4. Well, this is obviously not a cube. This happens to be the difference of perfect squares. And that one we know is x plus 2, x minus 2. Really easy. Number 12. We have 4k squared minus 9. Again, this is the difference of perfect squares. The square root of this right here is 2k, so that is my a, and the square root of 9 is 3, so that is my b. So it becomes 2k plus 3 and 2k minus 3. Okay, number 13. And we'll be done with factoring. We have 4x squared minus 25. Again, this is the difference of squares. So the square root of 4x squared, that's going to be 2x, and the square root of 25 is 5. So this is going to be 2x plus 5, 2x minus 5. And I'm going to stop now, and then we will continue in just a minute.